The key to understanding how to work molar heat of a reaction problems is understanding the concept of calorimetry. Do you recall the calorimeters and the fact that we talked about calorimetry in an earlier unit? Calorimetry is a study of heat changes using a device called a calorimeter. And if you have not already looked at the brief lesson on calorimetry, you should review that before undertaking this lesson. Here, let's try this problem. We take 2.4 grams of sodium hydroxide, those solid pellets, keep them dry now, until you add them to 100 milliliters of water in that same calorimeter that we've been using. And when we added it to the water was at 21.2 degrees Celsius. The water and the calorimeter were both the same. When we added that 2.4 grams of sodium hydroxide to it, the temperature rose to 24.3 degrees Celsius. And we need to calculate the molar heat of dissolving sodium hydroxide. Now remember that. It's going to come back to haunt you if you don't. Molar heat of dissolving sodium hydroxide. And the specific heat of the sodium hydroxide solution is 4.21 joules per gram degree Celsius. All right, here we go. The Q for the reaction. The Q for the reaction or the dissolving or whatever you want to call it. But the Q for the reaction plus the Q for the solution itself, that's the heat that is absorbed by the water and the solution that it's made, plus the Q for the calorimeter has got to equal 0. The Q for the reaction, which is what we are looking for. We're looking for the molar heat of dissolving sodium hydroxide. That's what we're trying to find. Plus 102.4 grams. Now, where did that 102.4 grams come from? Well, it's very easy. We took 100 milliliters of water at about a gram per milliliter. That's 100 grams. And we added 2.4 grams of sodium hydroxide to it. So we got a total mass of the solution of 102.4 grams. Got that? We multiply that by the specific heat of that sodium hydroxide solution, which is 4.21 joules per gram degree Celsius. And we multiply it by the change in temperature. Now, I was running out of room here, so I figured you could do the T sub F, the initial temperature, the final temperature minus the, I figured you could do the temperature, can't you? Yeah. Plus the 35 joules per degree Celsius, remember that is the heat capacity of that calorimeter, times 3.1 degrees Celsius, because that's the temperature that calorimeter is going to change. So it's going to absorb that heat, the heat that comes from that product right there, has got to equal 0. So Q for the reaction is equal to minus 1,445 joules for 2.4 grams of sodium hydroxide. But the problem asks for molar heat, folks. So take your 2.4 grams of sodium hydroxide, find out how many moles that is. It's 1 mole over 40 grams, yeah. That gives us 0.060 moles of sodium hydroxide. And that 0.060 moles of sodium hydroxide lost 1,445, it's the Q for the reaction was minus 1,445 joules. You've got to figure it for a mole, so take minus 1,445 joules divided by 0.060 moles, and lo and behold, you get minus 24,000 joules per mole. That's the way calorimetry problems are worked. Brought to you courtesy of the chemistry professor, providing complete courses in chemistry on DVD. Visit us at our website, chemistry